Okay, hi guys. So in this lecture, we'll be discussing first on the summary of the emission of different particles we just discussed in the previous lecture. So in summary, we can write that what are the particles first, particles conditions, effect and representation. Okay, so the particle is first alpha particle. So the condition for alpha particle to emit is z should be equals to, or z should be equals to 80, rather greater than 83. Effect is n by p ratio increases, and representation of alpha particle is 2 helium 4. Then we discussed beta particle. For beta particle condition is n by p ratio should be high, effect is n by p ratio lowers, and representation of a beta particle is -1 E0. Then we talk about positron or electron capture, positron emission or electron capture. So the condition should be again n by p ratio should be lower. As a result, effect is n by p ratio increases, and representation is +1 E0 for positron, and for electron capture it's same as -1 E0 electron capture. Okay, next let's discuss about gamma emission. So for gamma emission, conditions are high nucleus energy, and effect is low nuclear energy, or no low nucleus energy, and representation is gamma 0 0 0 gamma 0. Okay, now let us discuss nuclear stability belt. Okay, so the belt looks something like this. So here we have number of neutrons, and here we have number of protons. Okay, so and this curve should ideally be n by p ratio. Okay, and let's mark it as 20, 40, 60 and 80, and here as well 20, 40, 60 and 80. Okay, so what we see is after a certain amount of time, or rather till a certain amount of time, n by p ratio travels across this line, and after this it actually fluctuates and goes something like this. Okay, so at this peak, or at this point, or from this point onwards, we can say that higher n by p ratio is seen in atoms, and here we have, this is called zone of lower n by p ratio. Okay, so First, let's discuss the cases. So case 1 is that the graphs as look something like this, and versus P as something like this. So in the first case we are seeing the case which is a stable one. Okay, so where we can draw that. Before that, let this is the band of stability. Okay, and we will find many atoms having n by p ratio near to this band of stability. Okay, so we are discussing case 1 when we are discussing when the electron capture or positron emission takes place. Electron capture or positron emission. So when it takes place, so generally we have lower n by p ratio. So this means that we have, as this is the band of stability or the stable curve, we have many such curves tending to this band of stability or nearer to this band of stability. Suppose we have n by p ratio which is higher, or let's say this is for positron. Okay, so condition is n by p ratio is lower. Yeah, so when n by p ratio is lower, we can say that denominator would be higher, that's why it becomes lower, so p would be more than n. So what happens is this graph actually then tends to move towards this side. The n by p ratio would tend to move towards this side, towards z minus 1 from z. So moving here, a positron emission takes place wherein the atom X moves from z minus 1 xa with a positron emission. So just so as to lower the n by p ratio, means increase the n by p ratio, and which is initially the n by p ratio is lower, then n by p ratio increases. Okay, now let us discuss case 2. Again we draw the same graph between n and p. So this is the curve of stability or band of stability, and many other atoms would have graph near to or approaching to this band of stability. So suppose we have higher n by p ratio. Higher n by p ratio means p is less as compared to n, so we have a point somewhere here. Okay, so now what will happen is it will tend to move towards this curve. Okay, so as to increase its number of protons. So while it is increasing the number of protons, it should move something like this. This is the current coordinate of that particle, and this is also the current coordinate of this particle. So from the current position or current coordinate, it will move something like this, so as to increase z. So from z it goes on to having z plus 1. Okay, so if x was the atom, then it goes to z plus 1 with the emission of beta particle. This was the positron and this is beta particle. So this is the case when n by p ratio was higher, it goes to lower n by p ratio, with the emission of beta particle. Okay, so with this we come to the end of this lecture. In the next lecture we'll be continuing seeing more on the same. So till then, good luck and goodbye.